All right, friends, let's move on and take a closer look at correlation and computing the standard deviation of a portfolio. So because of correlation, to calculate the standard deviation of a portfolio, the movement of a portfolio, you need the weighting of each asset, you need the standard deviation of each asset, and you need the correlation coefficient for each pair of assets. How will each asset interact with all of the other assets in the portfolio? Okay? So you're not just pairing two assets together, you have to create pairs for each asset in the portfolio. Okay? This can be a very complex task for a portfolio that has a large number of securities. Okay? Fortunately, there's software available that can accomplish this. So you have to use software, but I want to take a look at a two-stock portfolio and give you an idea of how this concept of diversification and correlation work together. All right, so the standard deviation for a two-stock portfolio is equal to, wow, here it is, okay? There's your formula. All right, so let's go ahead and try to weight this thing out. Let's explain it. So XI is the weighting of IBM. So we have IBM and Walmart. So we have the weighting of IBM, and we have the standard deviation of IBM, and then we have the weighting of Walmart and the standard deviation of Walmart, and then we have PIJ, which is the correlation coefficient of IBM and Walmart. So the weight times the standard deviation plus the weight times the standard deviation plus 2 times the weights times the correlation times the standard deviations, all taken to the square root. So we're going to walk through this example. It won't take too long. And no, you will not have to do this in homework, and you won't have to do this on an exam. All right, but I want you to see the concept. All right, so the weighting of IBM is 40%, the weighting of Walmart is 60%. The standard deviation of IBM is 15%, the standard deviation of Walmart is 25%. So that would be a weighted standard deviation right there, okay? All right, the portfolio standard deviation is the weight of IBM times the standard deviation of IBM plus the weight of Walmart, and I don't know where these twos shouldn't be in here. Oh, this is raised, this is squared, this should be squared. These numbers should be squared. I have to get that done. It's not times 2, it's raised to the second, okay? So this would be 0.16, so you can, the weight squared times the standard deviation squared plus the weight squared times standard deviation squared plus 2 times the weights multiplied by the standard deviation, all raised to the 1/2. And here we go, let's get it down and let's see what the number is, and the number is 19%, okay? So this is the expected standard deviation for the portfolio, based on the historical standard deviations, based on the weights of the portfolio, and based on the historical correlations. This is the expected standard deviation of the portfolio, 19%, okay? Now, the standard deviation could change going forward. Historical standard deviations don't guarantee future standard deviations, and the correlation could change over time as well, okay? So that throws even more uncertainty into this. All right. Without factoring in correlation, let's take a look at the standard deviation, 21%. This is the weighted standard deviation, 21%. By combining these two assets that have a standard deviation of less than 1, we move the standard deviation of the portfolio from 21% to 19%, okay? Now, if the weightings were different and or the correlations were different, our expected standard deviation would change as well. If the correlation goes down, the expected standard deviation goes down. Okay? All right, so the result is that the standard deviation of the portfolio, because the correlation is less than 1, is 19% versus 21%. And again, as I just mentioned, note that correlations do change over time. Let's see, we got 2 more slides. All right, when you add a new security to a portfolio, you have two effects. One is the asset that you're adding, its standard deviation, okay? And 2, the correlation of returns between the new asset and the returns of every other asset already in the portfolio, okay? So as you look at the importance of these two effects, the standard deviation of the asset and the correlation of returns between the asset and every other asset in there, okay? Then the weight of the correlations becomes more important than the standard deviation of the asset itself. In other words, it is the interaction between the new asset and all of the other assets already in the portfolio that becomes more important than the standard deviation of the asset itself. Okay, that becomes more important. So the correlations with all the other assets in the portfolio is the key factor to consider when you're adding an asset. How will adding the new asset affect the correlations? You don't just look at the expected return. When you're building a portfolio, you don't just look at the expected returns of each of the stocks and bonds you're thinking about putting in the portfolio. You also have to be mindful of how these assets will interact together. That is a very important benefit. Too many times, investors and managers are looking for the hot stock to put into that portfolio. And that is not the right mindset, because you must factor in how adding that new asset will affect all of the correlations in the portfolio. That's what we're trying to get after. All right, last slide for this clip. So in conclusion, anytime correlation between assets is less than perfect, i.e. less than 1, adding the asset will reduce the variability of the portfolio, i.e. reducing the variability adds to the diversification of the portfolio. However, do not ignore the potential return associated with a security as you consider adding it to a portfolio. In other words, be mindful of both the return and all of the correlations. Okay, that will end this clip. We'll move to modern portfolio theory and we'll be finished with chapter 6. Until then, peace out. Shalom.